Hi, welcome to my channel. I'm your host GL, and today I'd like to talk about chromatography. Simply put, chromatography is like a chemical racetrack where different molecules run at different speeds through a medium, causing them to separate from each other. It's based on how strongly these molecules stick to or move through different materials. You know, I love explaining this to my students using a pizza analogy. Imagine you spill different sauces, ketchup, mustard, and mayo, on a paper towel. You'll notice each sauce spreads differently. Some travel further, others barely move. That's exactly what's happening in chromatography. The paper towel is our stationary phase, and gravity pulling the sauces down is like our mobile phase. Each sauce, or in real chromatography, each molecule, has its own personality that determines how fast it travels. The main types of chromatography are paper, thin layer, gas, and liquid chromatography. Each type uses different materials and methods to separate mixtures, kind of like how you might sort laundry using different methods, color, material, or temperature requirements. I tell my students it's like different types of transportation. Paper chromatography is like walking, simple but effective. Thin layer chromatography is like riding a bike, faster and more efficient. Gas chromatography is like flying, super quick but needs special equipment. And liquid chromatography is like taking a train, reliable and can handle heavy loads. Each has its own tickets and routes, if you will. The stationary phase is a fixed material that stays put, while the mobile phase is a fluid that moves through it, carrying the mixture we want to separate. They work together like a security checkpoint in a moving crowd. Think about going through airport security. The security checkpoint is like our stationary phase, it stays in one place. The people moving through are like our mobile phase. Some people, like those with lots of metal items, get stuck at security longer, while others zip right through. That's exactly how molecules interact with our phases. Some molecules are like the person with 3 laptops and metal jewelry, they're going to spend more time with security, while others are like the person traveling with just a phone, they'll get through much faster. Chromatography is used everywhere from drug testing and forensics to food safety and environmental monitoring. It's the go-to method when we need to know exactly what's in a mixture, whether it's detecting performance-enhancing drugs in athletes or ensuring your food coloring is safe. Here's a wild thought, you know those CSI shows everyone loves? When they're analyzing evidence, they're often using chromatography. It's like being a molecular detective. We can use it to check if your sports drink actually contains what it claims, or if that new perfume is authentic or fake. One of my favorite examples to share with students is how chromatography helped solve a famous art forgery case by analyzing the paint pigments. It's literally separating fact from fiction. The main factors affecting chromatographic separation are temperature, solvent choice, flow rate, and the quality of the stationary phase. These variables are like the rules of the game that determine how well our molecular race plays out. You know, it reminds me of making the perfect cup of coffee. Stay with me here. Think about how different your coffee tastes depending on the water temperature, how fast you pour it, what kind of filter you use, and even how finely ground the coffee is. All these factors affect how the flavors are extracted, just like in chromatography. Change any of these conditions, and boom, you get different results. I once had a student completely mess up their experiment because the lab was too cold, the molecules were moving like they were stuck in molasses. And by the way, if you are enjoying the video so far, do me a quick favor. Hit that like button. Really helps support the channel, and it only takes a second. Chromatography can identify unknown substances by comparing their behavior to known standards run under the same conditions. It's like having a fingerprint database for molecules. We can match the unknown substance's travel pattern to known compounds. It's exactly like being a detective at a high school dance. Let's say you find a mysterious footprint in spilled punch. To figure out who made it, you compare it to the shoes of everyone at the dance under the same conditions, same floor, same punch. That's what we do in chromatography. We run our mystery molecule alongside known substances and say, aha, this unknown compound traveled exactly like caffeine did. And just like that, mystery solved. The RF value is simply a ratio between how far a substance travels compared to how far the solvent travels. It's always between 0 and 1, and it's like a molecule's personal speed score in our separation race. Picture this. You're timing students running a 100-meter dash. If the fastest student, let's call him the solvent, runs 100 meters, and your molecule runs 60 meters in the same time, your RF value would be 0.6. Easy peasy. I always tell my students, if you can divide, you can calculate RF values. And the cool thing is, under the same conditions, a compound will always have the same RF value. It's like their chemical social security number. Chromatography is fantastic because it's precise, versatile, and can separate complex mixtures without destroying them. However, it can be time-consuming, expensive for some types, and requires skilled operators to get reliable results. Let me break this down like I do for my AP Chem class. The advantages are like a Swiss Army knife. It can do almost anything when it comes to separation. But the limitations are like having a Ferrari, amazing capabilities but expensive to maintain, and you need training to use it properly. I always joke with my students that some forms of chromatography are like having a $100,000 machine to separate red and blue M&Ms. But when you need to analyze blood samples or ensure drug purity, that precision is absolutely worth every penny. If you're looking for exercises to test your knowledge, there is a link in the description for you. Thanks for sticking around till the end. If you enjoyed the video so far and want to see more content like this, make sure you hit that subscribe button. Thanks for watching.